Welcome students. In this lecture, we are going to discuss second example of class interval data summarization. And just to recall the things, just to remind you that over here we are discussing the series of examples involving big data for the class interval data summarization. Now the question in hand is develop a class interval summarization for the following data set. Now this is our data set. If you compare this data set with the previous one that we discussed, the difference is quite clear. And the difference is that this data set comprised of real numbers and the previous one were just the integers. And when there are real numbers, then it basically means that we have certain precision. So it has a precision of one place after the decimal, while in the previous one there was no precision. So let's start with the summarization of this example in this data set. Over here, let me just cut down the slideshow so that we can do this example over here. So we have this template available, and in this template I have arranged the data in the table. And at first we are going to find the number of classes. So for this we need the total number of data set size, that is the total number of elements or values in it. Remember that number of classes is basically equals to log n upon log 2, where log n where capital N is the total data set size. And this can be easily determined without arranging them in descending order. This can be easily determined because it is in the matrix form. So we have basically 1, 2, 3, 4, and 5 rows, and 1, 2, 3, 4, 5, 6, 7, 8 columns. So it basically means that the total data set size is 4 by 5 by 8, that is 40. So capital N is 40. So if we replace capital N with 40 and we find log 40 by log 2, so what do we get? So log 40 divided by log 2, this is equal to 5.32. So this means that the result of this calculation is 5.32, and this can be approximated to a value which is 6. And this basically means that the total number of classes in our data set is 6. Now next we find the class height, and class height is range upon n. So for range we need the maximum and the minimum values of our data set. So we start with 4.7 in the first column, and we'll see that we'll check this 4.7 with every column. If we get a value greater than 4.7, then we will discard 4.7, otherwise we will retain it. So we can see that in the second column there is no value greater than 4.7. In the third column there is no value greater than 4.7. In the fifth column there is no value greater than 4.7. Then in the sixth, uh, in the sixth, yes, in the seventh we got 4.7 again, and in the eighth there's no value greater than 4.7. So 4.7 is our max value or the maximum value. And next we have to find the minimum value. So we start with 2.2, which is in the first column. Then in the second column we have 1.6. So 2.2 will be discarded and 1.6 will be taken as new smallest value. And as we see, no other value in any other column seems to be lower than 1.6, right? We have 1.9, which is close to 1.6, but definitely not lesser than it. So 1.6 appears to be the smallest value in the data set or minimum value. And the number of classes is 6 that we have already decided upon. And when we do this calculation of 4.7 minus 1.6 and then divided by 6, we get an answer which is equal to 0.516. So 0.516 is the result of this calculation. Now we have got 0.516, right? And now we have to be careful when working with the class height. Now our data set is such that it is precise to one place after the decimal. So whatever the answer comes over here for class height, we will just look till one place after this decimal. So we will discard every other value that is coming after zero point 0.5 and just focused on 0.5 as the value, right? And next what we have to do, so I just remove all the other things and just focus on 1.5. And in order to find the class height, this would be equal to 0.6. So we have to basically round up the first value after the decimal to the higher integer number. So 5 would be rounded up to 6, and basically this would become 0.6. So this would be our class height, right? And class width would be 0.5. So remember this thing. The class width would be 0.5, the unrounded figure, and the rounded one, 0.6, would be the class height. So let's start making our classes. So we start with 1.6. So we are going to add zero point 0.6 to 1.6, and this will be 2.2, which will become the lower limit of class 2. Then 2.8, which is 2.2 plus zero point 0.6, then 2.8 plus zero point 0.6 is 3.4. 3.4 plus zero point 0.6 is 4.0, and 4.0 plus zero point 0.6 is 4.6. Right? Next, we're making use of the class width. So 1.6 plus 0.5 is 2.1. Then 2.2 plus 0.5 is 2.7. Then 2.8 plus 0.5 is 3.3. 3.4 plus 0.5 is 3 for 3.9. Sorry, pardon me. It was 3.9, and 4.0 plus 0.5 is basically 4.5, and 4.6 plus 0.5 is equals to 5.1. So these are our classes. Now next comes the frequency. Now this is an important part and tiring job as well, but we have to do it to complete the class interval data. So from 1.6 to 2.1, what are the values that we have got? So from 1.6 to 2.1, there seems to be no value in the first column, but in the second column we have got one value. So let's mark it with some color. So let's mark it with the yellow color, right? Then we have from 1.6 to 2.1. In the second column, there seems to be no value. In the third, no. And then in the fifth column, there's no value. So 1.6 to 3.1, yes, there is one value over here, which is from, sorry, our range is from 1.6 to 2.1, so definitely this is not part of it. But 1.9 is a value that can be taken. So let's take this one. So 1.6 to 2.1, and then 1.6 to 2.1, right? Okay. So these are our values so far. So we have got the frequency equivalent to 2 in this case. So let's write this one. Okay. So the frequency is 2. I think this font color is much better than this one, but it's okay. So next is the frequency from 2.2 to 2.7. So if you miss any value, then it can be then later be compensated. This is the idea of marking them with colors, so it becomes easier. So 2.2 to 2.7. So 2.2 to 2.7. Then the second column there seems to be no value. The third 2.2 to 2.7. Then 2.6 comes out to be here. Then 2.2 to 2.7. There's no value. 2.2 to 2.7. Uh, the second last column from 2.2 to 2.7, and then over here in the last column we have got one value, so it's 2.61. So the frequency is 4 for this column. Then from 2.8 to 3.3, so 2.8 to 3.3 we have got one value, so let's mark it with, let's say, blue color. From 2.8 to 3.3, then this one as well. From 2.8 to 3.3, we've got just another one. 2.8 to 3.3, just another one. So 2.8 to 3.3. So there seems to be a lot of values over here. Frequencies, frequency is supposedly very high. Uh, Appears to be right now. And then we have got this one from 2.8 to 3.3. So 2.8 to 3.3, this one, and 2.8 to 3.3, this one, and third 3.0 will also be part of it. So the basic purpose of coloring is this, that in the end we may know that whether we have missed any value and whether the frequencies are in the correct cells, the correct in classes rather. So this is the basic idea of using the colors. So we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 is the frequency for this class. Then from 3.4 to 3.9. So let's mark it with a different color. So from 3.4 to 3.9, and this one as well, 3.4 to 3.9. We've got this one, 3.4 to 3.9. We have got this one. Okay, then this 3.7, 3.4 to 3.9. Then this one, 3.6, and then we have got this one, and then 3.9. So 3.4 to 3.9, we have got just another cell in this, and then we've got 3.9 completely present, 3.4 to 3.9 this one, and the last two. So what is the frequency then? So we have got to count all the green color cells. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So again the frequency for this is 13. Then from 4 to 5, so 4.0 to 4.5, let's mark this one. So 4.0 to 4.5, let's mark this one. So 4.0 to 4.5. So 4.0 to 4.5, let's mark 8, 4.0 to 4.5, and this one 4.0 to 4.5. So we have to now count all these orange colored cells, and this appears to be 1, 2, 3, 4, 5, 6. So frequency is 6 for this one. And lastly, 4.6 to 5.1. Those two are remaining in it, so just let's mark them with some different color. So 4.7 and 4.7. So the frequency is 2. Now if we sum all these frequencies, so what the result comes out to be, so 2 plus 4, and then plus 13 plus 6 and plus 2. So let's count it again. So 2 plus 4 plus 13 plus 13 plus 6 plus 2, and the result is 40. So this should be, because this is the total data set size, total frequency should be equals to 40. Next comes the relative frequency, and relative frequency is the same thing as the probability of the class, and it's basically equals to frequency of the class divided by total frequencies that we have got. So it's like 2 by 40, 4 by 40, and then 13 by 40 and 13 by 40 for the next two classes, and then 6 by 40, and then in the end we have 2 by 40. So we have 2 by 40 over here. Okay, and the sum of all these frequencies is equal to 1, as should be, because it is the probability value. So the sum of the all the mutually exclusive events is basically equals to 1. The sum of the probabilities of all the mutually exclusive events is equals to 1. Then we have got to basically sum the frequency, so it's like 2, and then we have got 6, and then 13 plus 6, sorry, yep, 13 plus 6 is 19, then 19 plus 13, and let's do this sum. Of 19 plus 13 is 32, then 32 plus 6 is 38, and 38 plus 2 is 40. So this 40 should be equal to the total number of frequencies that we have got. We are just summing the preceding frequencies, like we summed 4 with 2, then 13 with 6, and 13 with 19, and 6 plus 32, and then 2 plus 38. For the class boundary, first we have to find the jamming factor, the factor that is used to bond the classes so that they become continuous. And remember, this is equivalent to, the jamming factor is equals to lower limit of the class minus upper limit of the class. That is lower limit of class 2 minus upper limit of class 1 divided by 2. So it goes something like this, like 2.2 minus 2.1 divided by 2. So 2.2 minus 2.1, and then divided by 2 makes it equals to 0.05. The jamming factor is 0.05. And now what we have to do is basically subtract the 0.05 from every class, lower value, the lower limit of every class, and add the 0.05 to the upper limit of every class. So we have to subtract 0.05 from the lower limit of the class and add 0.05 to the upper limit of the class, and this have to be done with all classes. So when we do this thing, so it's like 1.6 minus 0.05 is basically 1.55, and this goes to 2.15. So 2.1 plus 0.05 is 2.15. Then we have, and for the second class, it is 2.15 to 2.75. Then from 2.75 to 3.35. Then from 3.35 to 3.95. And then from 3.95 to, we have got 4.55. And then from, sorry, then from 4.55 to 5.15. So it goes to 5.15 in this way. So that's how we basically complete our class boundaries, and we can see that they are perfectly well, because the number at which a class boundary is ending is the same number at which the other class boundary is starting. The last column is the class mark values. Remember, the class mark values are the middle values of the classes, and they are the average values, and they are calculated in this way, that we basically add the two the values, that is the lower limit and upper limit of the class, and divide it by 2. So that's how we find the class mark value. So for the first class, it goes something like this, like 1.6 plus 2.1, and then divided by 2, and this gives the answer, which is 1.85. So it's 1 point, sorry, 1.85, and then 2.2 plus 2.7 divided by 2, we get 2.45. Then we have 3.8 plus 3.3, and then divided by 2, we get 3.55. Then we have 3.4 plus 3.9, and divided by 2, we get 3.65. Then for the second last class, 4.0 plus 4.5 divided by 2, we get 4.25. And in the end, for the last class, we have got 4.6 plus 5.1, and divided by 2, we get 4.85. So that's it. So this completes our class interval table, the summarization of the data set that was given to us, and I hope this is understandable to you. I had already done this example, so let's see if we have got the same results. So we have got the same results, and this means that we have done this thing uh, correctly. But uh, let's just check one thing. There seems to be a little difference in the third class, the class mark of the third class. So just let's check it out. So we have got 2.8 plus 3.3, and when we divide it by 2, we get 3.05. So this was a little typo, so it's 3.05. So now we have got all the results correct, and they are all the same. So it means we have done the work correctly. So that's how we do this class interval summarization for this data set that was given to us. If there are any queries, any confusions, any questions in your mind, then you can write down in the comments, and I'll get back to you to resolve your questions. So thank you very much. Stay safe, stay healthy.